second-hand jumping is common on today's quartz watches. In the past, the second hand moved with each beat of the escapement 5 times per second. Between these technologies, the Accutron was born. This watch does not tick, it hums as the second hand moves smoothly around the dial. Now let us meet Accutron expert Henry Frystak, who will lead us through the intricacies of servicing the Accutron caliber 214.
Oh, hello. I am Henry Frystak, former senior instructor at the Field Training Department of the Bulova Watch Company. I conducted hands-on bench seminars on the Accutron watches for 12 years all over the United States. On this video, I will show you how to disassemble, service, assemble, adjust, and regulate the Accutron Model 214. The 214 is the first of 6 different Accutron models Bulova produced. Appearing on the market in 1960, the Accutron was the first wristwatch that would guarantee an accuracy of a minute a month when worn on a person's wrist. But it can keep even better time than that if it is adjusted and regulated properly. It was one of the first wristwatches ever accepted as a railroad engineer's timepiece. It was also used in ship's chronometers, in long-term switching timers and instruments left on the moon. This movement uses a vibrating tuning fork as a time standard, as opposed to the balance wheel and hairspring. It took 5 years by Bulova engineers and a Swiss physicist to develop it into a very fine wristwatch. It is actually a microsonic timepiece that uses a musical tuning fork, vibrating at 360 times a second as a time standard. It took some smart brains to design the electronic circuit which keeps the fork vibrating, and to harness that fork to drive the index wheel and the train to operate the hands, and to miniaturize this to work in a wristwatch. To repair this watch, you will have to learn the names of some new parts and some new terms, such as the fork, the coil assembly, index wheel, index and pawl and fingers and jewels, safety bridge, the pawl bridge, shock bridge, index guard, frequency, amplitude, phasing, and prepositioning. These are the tools you will need to repair Accutrons: an Accutron test meter, a 30-power microscope, a special 214 movement holder, eye loops of 5 and 10 power, fine steel hairspring tweezers, non-magnetic tweezers, 4 or 5 sizes of watchmaker screwdrivers, a working stem, a post-bending tool, a hand remover, Rodico or a similar product, pithwood, pegwood, oil and an oiler, a case wrench, and an index wheel holder, and 3 homemade adjusting tools which will be described later. A high-intensity lamp and a copy of a 214 manual would come in handy. Use a special plastic movement holder with locating pin and notches cut to accommodate the working stem. The other side of the movement holder is cut for use in removing the coil assembly for the movement, and a notch where a connecting plug from the Accutron meter plugs in. An Accutron meter is a must when working with Accutrons, and when plugged into the movement holder, the wire contacts provide current to the movement. The meter can provide 2 different voltages, a full battery voltage of 1.35 volts for running and a lower voltage of 0.95 for phasing. A phasing is a process of synchronizing the indexing mechanism. A microscope of 20 or 30 power with at least a 2-inch working distance is necessary when straightening and prepositioning the index and pawl fingers and jewels. It is also necessary for phasing and especially when adjusting the index guard. These are the 3 homemade tools you should use in assembly: pre-positioning, positioning, phasing, and adjusting the index guard. These tools are not absolutely necessary, but they make the job much easier. The pawl post pushing tool is made by grinding the eye of a large needle to a shape like this. The index guard raising tool is made from a large sewing needle ground to this shape. The wheel locating prod is made from a steel wire bent and ground to the shape shown here. A working stem such as this can be made from a piece of material that makes a snug fit to the hole in the edge of the movement. Before working on the watch, it would be wise to familiarize yourself with the pictures and names of the parts. A pillar plate assembly, the tuning fork, a coil assembly, a train bridge, the center bridge, the ground strap, the safety bridge, the shock bridge, the lower jewel plate, a coil lead retainer plate, the pawl bridge, the setting wheel spring, minute wheel spring, center second brake spring, the index guard, the center second chaton jewel, the center second pinion, the setting wheel and pinion, the minute wheel and pinion, the index wheel and pinion, the second wheel and pinion, the third wheel and pinion, the fourth wheel and pinion, the center wheel and arbor, the hour wheel, the cannon pinion, the setting stem, the pawl bridge cam, and the dial holding nuts. Before proceeding, listen for a hum. If a hum is heard, electronics are probably okay. If no hum is heard, check the cell. If the cell is good, the problem is probably an open circuit or a bad coil. First step in disassembly is to remove the cell by unscrewing the cell hatch or battery cover. A dime or penny fits the slot perfectly. Remove the locking ring. The case back. And the gasket. Carefully remove the movement from its case. The movement has a 1.45 millimeter hole at the 12 o'clock position for insertion of the working stem that frictions into it, making it easier to handle while working on the movements. Place the movement into the movement holder dial side up. Remove the hands with a hand remover. Pull off all 3 hands at the same time. Be sure to use a thin piece of plastic over the hands and dial for protection. Be careful not to move the second hand either backward or forward when taking the hands off or putting them back on. This could cause great damage to the indexing mechanism. Turn the movement over in the movement holder and remove the 2 dial holding nuts. The dial holding nuts are tubular, threaded on the inside, and go in from the back of the movement near the middle of the movement. They screw onto threads on the dial legs. Turn the movement over, place into the movement holder, and lift off the dial. Now, while you are on the dial side of the movement, you should remove the hour wheel and dial washer, the set spring screw, the set spring and minute wheel springs. Remove the minute wheel and the set wheel. Remove the cannon pinion. The cannon pinion does not slip on the center post as on mechanical watches. The center wheel is so designed that the center post slips in the center wheel. This way, the friction can be controlled better. In the first model, they had conventional cannon pinions and sometimes were too tight, thus spinning the whole train and damaging the index wheel. At this time, remove the shock bridge. The purpose of the shock bridge is to limit the amount of the distance the fork could be allowed to move or bend. If the watch were dropped on the dial side and possibly overstressing the fork. If a fork is overstressed, it will lose time beyond regulation limits. Notice the shock bridge screw is a flathead countersunk screw. It fits flush with the top of the shock bridge. Because the hour wheel rides on the shock bridge, it must be smooth. Also at this time, remove the double cap jewel. Now turn the movement over and place it into the movement holder. Next, remove the safety bridge. The safety bridge, as the name implies, protects the index and pawl fingers at the time the stem is being put through the opening when you will be casing the movement. The opening hole is near the index and pawl fingers. The index guard is a device to keep the index and pawl jewels from falling off the edge of the very thin index wheel if the watch is given a bad bump or shock. The index guard straddles the index and pawl fingers near the end of the fingers. You must be careful when moving the guard away from the fingers, and especially careful when putting it back after phasing. The screws should be tightened to hold the guard out of the way while working on the movement. Being careful now will save work later. The guard must be turned out of the way before you remove the fork. Since the guard straddles the index and pawl fingers, serious or even fatal damage can be done to the index finger if the guard isn't turned away before raising and removing the fork. I advise you to do it now so that you won't forget to do it later and ruin the index finger. When cleaning or disassembling the movement, the pawl jewel should be backed away from the index wheel. To do this, you must loosen the pawl bridge lock screw, then turn the cam so that the pawl bridge rises to its highest point. The pawl jewel will also rise to its highest point away from the wheel. Then the lock screw can be retightened. Remove the screws that hold the center chaton jewel. Notice the large heads but very small threads. These screws are made in 3 different sizes of threads. If the chaton screw threads in the bridge are stripped, larger threads are available. They are denoted by the color of the screw heads. White is standard, gold is larger, blue is the largest. Remove the chaton jewel. Then reach down with tweezers and pull out the sweep second pinion. Notice the plastic washer under the pinion. This does not come off for cleaning purposes. Also, this washer need not to be oiled when reassembling. The sweep second pinion, however, must be out of the movement when cleaning and later reassembling. You will need to look under the bridge with the microscope to examine and adjust.
if necessary, the index and pawl jewels. They must be centered and perpendicular to the index wheel. The sweep pinion would block the view of these jewels if it is left in. Remove the movement from the movement holder, turn it over to the dial side, and replace it into the movement holder.